So, in your reading of Chapter 5, you may have noticed that there's a lot of different blanks that we talk about. So what's the point in having so many different things that we call blanks? Well, let me take you way back. Hopefully it's way back. Hopefully it's not something you've done recently. Hopefully you've moved on from that and you're doing better. Now suppose you're doing a Beer's Law experiment, just like in Gen Chem 1 and 2, and so you're about to go put that test tube into the spectrometer, and you need to do your zero measurement. For that, you're going to use a blank. What did you put in that blank? Well, if you're measuring the concentration of a dye, in all likelihood, you probably just put DI water in there and called that your blank. Fine, that'll be our most crude version of a blank, but what about all the other things that were there? Now suppose for a second that we were just trying to find the concentration of the green dye present in lemon lime Kool-Aid. Well, what about the other things that were inside of that Kool-Aid? We also have the flavoring components. We have maybe another dye. We probably didn't have a buffer, but that's another example of something like this. There might have been some sugar substitute. If it was the sugar-free version, you can see there's other things that would be present. Now, what we can do, we can go ahead and add in these other things to the DI water and leave out the absorbent compound that we're actually going to measure. In other words, this blank is going to be everything else that's present, just not the thing that we are trying to measure. Now that's going to be something called a reagent blank. And the point of that is that we actually have all the same substances in there. The thing is also, though, we haven't gone through all of the steps. If we were measuring Kool-Aid, we actually had to tear the packet, pour it out into the pitcher, add the water, mix it. Here we didn't necessarily use all those same steps. When we add in the steps, like maybe the wooden spoon grabbed hold of some of our matrix, maybe there was some carryover from that wooden spoon onto the matrix, in other words, into our water in the Kool-Aid. Maybe we had things in the glassware each time that we mixed things. Maybe the components started adhering to the plastic pitcher. We're going to subject it to the complete same makeup with all of this stuff as we do with the actual Kool-Aid packet. Now we call it a method blank. In other words, reagent blank is when you take this stuff and you just mix it real quick in labware. Method blank is when you go through the entire experiment, doing every step and every piece of sample handling the exact same way as you're going to do for your real sample. That way any other things that are hiding in there, like dirty glassware, things like that, start to kind of entangle and they show up in your blank. Now suppose that you're actually trying to go out into the field and you're trying to collect an air sample or a water sample, but you're also going to have to then take it back to the car. There's going to be all these other transit steps. All those things are going to end up starting to collect some of the other materials. So for that, we're going to need to do some sort of a field blank. That's going to help us control for that. And so you can see that there's going to be a lot of different kinds of blanks. And in our workshop packet, we see a few other kinds of blanks. In other fields, you'll see that there's more kinds of blanks. We aren't going to worry about going that far down that rabbit hole. The key part of it is I wanted us to recognize that there are times where we can make a simple blank in the lab. Something as simple as just DI. Other times we need to get a little bit better. So maybe if we're doing a measurement of a dye in a buffer, we better be blanking it with the buffer. If our buffer sometimes has methanol and sometimes doesn't, we better be blanking with the one with the buffer and methanol. And if it matters enough, we should be treating it to all the sample handling, especially if it's a really complicated and sensitive measurement we're trying to do. Now, if it's something as crude as, or not crude even, if it's something as standard as most analytical measurements that we do in other fields, we're probably in okay shape doing a reagent blank, where we're at least using the buffer instead of deionized water. to blank out our spectrometer. But if we're trying to get down to nanomoles, if we're trying to really do sensitive measurements, if the compound we're looking at has a really strong activity, and by activity I don't mean activity coefficients, I mean, maybe you're working with some sort of a toxin that manages to kill at very tiny concentrations, then you really want to be making sure that none of that's being carried over, and part of the way you can do that is by using an appropriate blank, so that you're always making sure things are well calibrated so that you never have any tiny jitter adding in and throwing off a sensitive measurement. As you get more and more sensitive, or as your sample gets more and more rare or expensive, build better and better blanks in, because you can't afford to fix blanks by doing it again anymore. You've got to do it as perfectly the first time as you can, and for that you got to have high quality blanks.